TMFL. All that good stuff. Greetings and salutations. We are now live. Much love to all of y'all. Episode 205. Welcome to you guys. Much love to everyone. Today's going to be a Spear Shaker Star special stream. Saturday. We're going to put 5 S's in there. It's Saturday Spear Star Space Stream Special. Let's make it 6 S's in a row. Yeah, guys, that's definitely something that I've been giving a lot of thought about, and we're definitely going to be heading and continue to head in that direction, that general direction, where we want to make at least my love with for gaming, and obviously with what is above us, regardless where we are in the world, it's always above us. Check that out as well and see if we can kind of really marry those two passions that I have, I guess. So yeah, today we're going to be talking about a lot about space and the stars, and especially about black holes and the fact that there are binary black hole systems, which also merge, and it's actually precisely this the resulting gravitational wave, which we modern man have now been able to pick up. So it's gonna get, I don't want to say like technical here because I'm not like an astrophysicist, but I guess there are some basic fundamentals of physics which one should have to kind of be able to try to comprehend what we're going to do here today. So, just a second here. So, yeah, we are going to be talking a lot. Sekra, good day to you. I'm definitely not a physicist. This is, well, it's not even a physicist. I like an astrophysicist, right? But welcome, by the way, Sekra. So, yeah, today we're going to be talking a lot about what has even been been compared to what happened 2 days ago in LIGO headquarters, or LIGO headquarters, was described as fundamental for modern astronomy, as 400 years ago, Galileo putting his spyglass into the sky. So let's watch a couple of videos here and see what kind of. Press this button just like that. I think that will be a good thing. And then we also actually want to press this, and let's get into. Sekra says, as long as we don't talk about the moon, what happens on the moon stays on the moon. True that. We can get into the moon as well, but today we're going to be talking about LIGO, we're going to be talking about gravitational waves, we're going to be talking about Einstein. 100 years ago exactly, Einstein was saying, you know what, guys? Gravitational waves. For my theory, which you guys are all thinking is crazy, for my theory to work, these things have to exist. 100 years later, boom! It's like, guys, gravitational waves, not only do they exist, we can see them. Like, so it's an extraordinary, amazing time right now. For modern astronomy, what happened 2 days ago, I'll say this again, try and keep it in context here. For modern astronomy, for modern man, I guess, what happened 2 days ago will revolutionize just as much as Galileo pointing his spyglass into the sky. We're going to be seeing things towards which we were completely blind before. It's like after the telescope came the radar, right? You're shoving radar waves up there, and they're bouncing back. And you're getting X-rays. We're watching the universe through this visible and non-visible spectrum of of energy, right? This photon energy. Now we're going to be actually realizing time and time space being compressed, and we can actually see this happening, tune into it, and thus see all the other cataclysmic events that happen above us. So let's just get into a video here real fast. Let's press this button right here and actually kind of have people speak about things which they actually know about, unlike me. Okay, so let's pump up the volume here to the max, and I'll try and be quiet because this is huge, guys. Bob, not the builder, but the frag Bob. He yesterday just on Sky, like, look at this spear shaker, quite interesting. It's fucking, it's revolutionizing. That's what it's. Here we go.
Ladies and gentlemen, we have detected gravitational waves. We did it.
It's fucking sick. It's sick. We did it. Yes, we can. Yes, we can.
I am so pleased to be able to tell you that. So these gravitational waves were produced by two colliding black holes that came together, merged to form a single black hole about 1.3 billion years ago. They were detected by LIGO, the Laser Interferometer Gravitational Wave Observatory. LIGO is the most precise measuring device ever built.
Okay. LIGO is the most precise piece of equipment ever built, says the Homo sapiens sapiens in 2016. That in itself. Let's carry on now.
We start with what we saw. So on September 14th, 2015, the two LIGO observatories in Hanford, Washington, and Livingston, Louisiana, recorded a signal nearly at the same time, nearly simultaneously, and the signal had a very specific characteristic. The characteristic of, as time went forward, the frequency went up. And what was amazing about this signal is that it's exactly what you would expect, what Einstein's theory of general relativity would predict for two big massive objects like black holes in spiraling and merging together. Now, it took us months of careful checking, rechecking, analysis, looking at every piece of data to make sure that what we saw was not something that wasn't a gravitational wave, but in fact it was a gravitational wave. And we've convinced ourselves that's the case, and we're here to announce that today. But I do want to say something else. This is not just about the detection of gravitational waves. That's the story today. But what's really exciting is what comes next. Right, it's 400 years ago, Galileo turned a telescope to the sky and opened the era of modern observational astronomy. I think we're doing something equally important here today. I think we're opening a window on the universe, the window of gravitational wave astronomy. So I'm going to show you two videos that are going to sort of tell you what we discovered. So the first video is the two black holes. So what you're looking at on the screen here are two black holes. Each of them are about 30 solar mass, have about 30 times the mass of the sun. All right, and you're looking, the black holes are the black things in the middle, and you're looking at the stars behind them. By the way, this is not a Hollywood production that I'm going to show you. It is actually a real computer simulation solving Einstein's equations for these merging black holes. So this is really what it would look like if you were in a spaceship close up. And I will also point out that the movie I'm showing is vastly slowed down relative to what happened here. So let me start it. All right, you can see that as the black holes spin around each other, all right, the stars behind them are warped, and that's because the strong gravitational fields bend the light that comes around. But what I want you to pay attention to in this video is the fact that as they orbit, the black holes are getting closer and closer to one another. The orbit is speeding up, and eventually they're going to merge. The event horizons are going to join, boom. They produce one big black hole, which relaxes, and you see a little bit of vibration there, and it becomes two smaller black holes die, one bigger black hole is born. Now, what's really amazing about this is the first time that this kind of a system has ever been seen, a binary black hole merger, and it's proof that binary black holes exist in the universe. So I want to put this in perspective for you.
That is so. This gentleman here, he's just bombarding us with just mind-boggling things. Not only is he saying, okay, we the scientific community say what Einstein said 100 years ago is correct. For him to have made sense, these things had to exist, and we can now say, you know what, Einstein, you were ahead of your time. But he can also say, you know what, guys, binary black holes, binary merging black hole systems, they exist. We kind of suspected that, but now we can actually say they exist. 2 days ago, like on paper, they have to exist, but we had no idea. Now we can tune in to the universe in a manner that is just absolutely mind-boggling. This time in a decade, new categories within modern science are going to show up and just pop up out of. It's going to be amazing stuff. Let's carry on here. What he says next actually is just going to be incredible. He's going to actually going to put into context what these black holes are like and what they're doing. It's just unbelievable.
Because I think it's very important, all right, to give a sense of what really happened here. So each of these black holes are about 150 kilometers in diameter, a little bit bigger.
150 kilometers.
Take something that's 150 kilometers in diameter, so that's about
it's nothing.
A little bit bigger, maybe a lot bigger than the metropolitan Washington, D.C. area. Pack 30 times the mass of the sun in that. Accelerate it to about half the speed of light. Now take another thing, 30 times the mass of the sun, accelerate at half the speed of light, and collide them together. That's what we saw here. It's mind-boggling. All right, now, let me talk about...
Mind-boggling is the understatement of human history. This is not mind-boggling. This is just like... This is a giant leap for mankind. This truly is a giant leap for mankind. Crazy stuff. It is, for me, this is like personally so exciting. It's incredible. Incredible stuff. Guys, I hope you're all enjoying this video. We're going to carry on here and listen to this very intelligent man speak about not so simple to comprehend stuff, I guess.
About the gravitational waves. You didn't see any gravitational waves there. What you saw was actually black holes. Now let me look at this from the gravitational wave perspective.
Check out this video.
So, again, a computer simulation. This is a real simulation using Einstein's equations. You see the two black holes. And the green that you see are the gravitational waves that are produced as the black holes orbit around one another. Their orbit decays and they merge together. All right. So they're spinning around. You see they're getting closer and closer together. As they get closer and closer together, more gravitational waves. They
boom,
merge,
look at that ripple.
And there's this burst of gravitational waves that travels for 1.3 billion years. It passes through everything. It goes right through matter, right through stars, and it eventually gets to the Earth.
That is insane.
Right? When it gets to the Earth, the gravitational wave passes, and what it's going to do...
Look at the planet. Look at our home.
As these waves pass, and you'll see that the Earth is jiggling like jello. I don't want people to be scared here. The Earth doesn't really do this. This effect is greatly exaggerated, but it gives you the effect. And then we zoom in, and how we detect these are using the interferometer that's in LIGO. And Ray Weiss is going to tell you more about the interferometer.
It's a crazy piece of equipment.
That the effect that we're trying to measure from these violent, these big black holes colliding each other at half the speed of light, all right, is so tiny that it takes something like LIGO to measure it. We are trying to measure things basically at 1/1000th the diameter of a proton. That's the size of the sun
1/1000th of a proton.
1.3 billion years away. All right. Let me put that in perspective because I think...
Listen to this. Listen to this perspective.
All right. If we were trying to measure the distance between the sun and the nearest star, which is about 3
Alpha
and a quarter
Centauri.
light years away, LIGO is capable of measuring that, if it could do that, to a level of about the width of a human hair. So the width of a human hair over 3 and a quarter light years.
That's insane.
Remarkable precision. Right? Now, what LIGO does is it actually takes these vibrations in space-time, these ripples in space-time, and it records them on a photodetector, and you can actually hear them. So what LIGO has done, it's the first time the universe has spoken to us through gravitational waves. And this is remarkable. Until now, we've been deaf to gravitational waves.
Yep.
We're able to hear them. That's just amazing to me. I think this is big, again, because what's going to come now is we're going to be able to hear more of these things. And no doubt we'll hear things that we expected to hear, like binary black holes or neutron stars colliding. But we will also hear things that we never expected.
What's this now? Oh,
we
yeah.
open a new window in astronomy.
Oh, yeah.
Never
Exciting times, people.
So let me conclude by thanking the National Science Foundation. For 40 years, since the NSF started funding Caltech and MIT to do pilot experiments for LIGO, and then in 1992, the NSF went ahead and funded the LIGO project, right? And they took a big risk, all right? This was bold. The science was solid, but we didn't know how many events we would see. The technology was nowhere near developed. This was truly, I think, a scientific moonshot. I really believe that. And we did it. We landed on the moon. So
We did it.
so I
We
really
landed
wanna
on the
thank
moon.
Cordova and
Okay.
and also U.S. Congress, the taxpayers who've supported this research, because it's really, really gotten to the point now where it's going to take off.
Good stuff, guys. Absolutely insane stuff. So let's look at this through the website that I like to use a lot, called Earth Sky. I like this quite a bit, I have to say. So this is basically what we're talking about here. Gravitational waves have been detected by LIGO, who basically stands for this the laser something infraspectrometer or something. Here we have a nice picture. Again, it says that the gravitational waves are created in some of the most violent events in our universe. Chris C., welcome, brother. Welcome. Thank you for being here. Again, like two black holes, like colliding with each other at half the speed of light. That's a pretty violent event, I would say. The merging of two black holes. That's just incredible. The science world was buzzed with rumors about this morning's announcement by LIGO all week, but now it's actually for real. These guys for the last 4 months have been they thought, like, this cannot be. Like, we're not able to detect this. We shouldn't be able to detect this. They were searching for exactly this. It's not like they were like, oh, stumbling across something, but just incredible.
Here's Johnny.
Sergio's in the house. Welcome, Pinchy. Much love to you, brother. Let's look at this. Let's try and actually understand what these gravitational waves are actually about. This is a nice video as well. I watched all of this stuff this morning at work. It's great times. Let's check this out.
What is a gravitational wave? It's a ripple in the fabric of space and time. Imagine that space is a giant sheet of rubber. Things that have mass
Thank you,
cause the
Sakura.
rubber sheet to bend, like a bowling ball on a trampoline. The more mass, the more that space gets bent and distorted by gravity. For example, the reason the Earth goes around the Sun is that the Sun is very massive, causing a big distortion of the space around it. If you just try to move in a straight line around such a big distortion, you will find yourself actually moving in a circle. That's how orbits work. There's not an actual force pulling the planets around, just a bending of the space.
Let's just hear that one more time. When I heard this,
Force pulling the planets around, just a bending of the space. How orbits work. There's not an actual force pulling the planets around, just a bending of the space.
there's no force. It's just you bending this space-time continuum. It's remarkable stuff.
Waves are produced whenever masses accelerate, changing the distortion of space. Everything with mass and or energy can make gravitational waves. If you and I started to dance around each other, we would also cause ripples in the fabric of space and time, but these would be extremely small, practically undetectable. Now, gravity is very weak in the scale of other forces in the universe, so you need something really, really massive moving very, very fast to make the big ripples that we can detect. How would you observe a ripple in space? If the space between you and me stretched or compressed, we wouldn't notice it if we had made marks on our metaphorical rubber sheet, for example, using equally spaced rocks, because these marks would also get stretched further apart. But there is one ruler that doesn't get stretched, one made using the speed of light.
Speed of light, baby.
If 2 points get stretched, then light
We're-
will take longer to go from one point.
We're learning about gravitational waves today, Sergio. We're gonna stay in space. There's not gonna be much gaming happening today. We're celebrating this huge discovery. Yeah, space stuff, kind of, for sure. Like in short, yeah, that's what it is.
To the other. And if the space gets squeezed, light takes less time to cross the 2 points. This is where the LIGO experiment comes in.
This is very
As
important.
four
This is to actually.
points get stretched, there's one ruler that doesn't get stretched.
This is
One
how it
made
works.
using the speed of light. If the space between 2 points gets stretched, then light will take longer to go from one point to the other. And if the space gets squeezed, light takes less time to cross the 2 points.
It's
This
that
is where the
simple.
LIGO experiment
It's that simple.
It has 4-kilometer-long tunnels and uses
Thank you,
lasers
Red Eye.
to measure the changes in the distance between the ends of the tunnels. When a gravitational wave comes through, it stretches space in one direction and squeezes space in the other direction. By measuring the interference of the lasers as they bounce between the different points, physicists can measure very precisely whether the space in between has stretched or compressed.
That is
And
just-
the precision needed is incredible. To detect a gravitational wave, you need to be able to tell when something changes in length by a few parts in 10 to the 23. It's like being able to tell that a stick 1 sextillion meters has shrunk by 5 millimeters. The effect of a gravitational wave is so minuscule and easily confused with random noise, you need a smart data analysis technique.
Yeah,
Scientists
Chris,
look
for
to
sure.
identify the patterns of
For sure,
gravitational
Chris.
waves by comparing the wiggles they measure in the experiment to the wiggles they expect from the gravitational wave.
We're now
That's like
tuned
trying to
into the
identify
universe in
someone
a manner.
at a noisy party, a very, very noisy party. Imagine your whole life you had been deaf until one day your hearing was restored. You'd be able to explore the universe in this whole new way. That's why detecting gravitational waves is so significant. It's a completely new way of studying the universe. Anytime there's a new way to investigate the universe, we discover things we didn't expect. It's really about looking for new things we didn't know existed, examining the extreme edges of our knowledge of physics, and testing our theories about how the universe works.
It's great stuff. This is a great video. Great video, guys. Here we see one of these engineers dealing with their stuff. This is just absolutely crazy times, guys. Again, Einstein said 100 years ago, man, 100 years ago, he was saying, guys, this is what's going on, and these things also have to exist. And it takes us, modern man, 100 years to be like, yeah, okay, Einstein is actually right, even on this point as well. It's absolutely incredible, guys. It's like it truly is, well, not for us amateur astronomers, I guess, but for the professionals all over the world, you know, if you throw enough money into this now, and if you want to truly tune into another form of the universe talking to us, then that's just amazing. It's like we've been blind. Well, it's just absolutely incredible. I am so excited about this. Absolutely incredible. Absolutely incredible. Let's look at some other footage here from space.com, another website that I obviously like to. It's all over the guys. It's headline news all over the science community. It's absolutely incredible. Where were we here? Gravitational waves. What their discovery means for science and humanity. Can you guys even see that half decently? I hope so. Again, this is all 2 days old now. This is February the 11th. Again, the scientists, they didn't, and you know, they announced 2 days ago that They didn't discover this 2 days ago. For the last 4 months, they've literally been like rechecking, confirming, is this actually what we believe this is? Absolutely incredible. Let's have a look at this video here. I haven't been here this morning, so let's look at this.
It's a catastrophic event we just observed. Two black holes, originally in a nice pair, like the Earth is going around the sun, but now
What's up, Sneebro?
they're losing energy due to the emission of
Look at this.
gravitational
Look
waves,
at
they're
this.
coming
Sneebro,
closer
welcome.
and closer together until a catastrophic merger happens, destroys the binary, forms a new black hole.
Boom.
This in itself is the most powerful event we have ever detected as observers of the universe. The big discovery.
As observers of the universe, this is the most cataclysmic event. The energy release, it travels for 1.45 billion years. It's like it just messes with everything. Cosmic pig nose. G to the G. What's up, Red Eye? Spear Shaker, see me and the Mrs. Perla collection so far. What? I don't understand. Yeah, you've been doing this. GG. Let's check this out. This she's Italian.
We're experiencing now has to do partly with this direct observation for the first time of gravitational waves emitted directly from a black hole and being detected directly by instruments on the Earth.
Incredible stuff.
The structure of the universe.
Frag Bob. Bob, this is all your fault, Bob. Bob, welcome, my brother. This is all your fault, man. You messaged me yesterday with that link. I was streaming. I wasn't kind of, I kind of, didn't see what it was about. Like I didn't understand like the consequences, the upcoming consequences of this event. I'm just blown away, Frag Bob, and it's your fault. The art project, we are starting to have some side business. Good shit, Red Eye. Good shit. 258 Consuela is now an astronaut? No. Yeah, that's Bob. Come on, you mentioned that yesterday, dude. Like, what, brother? Come on. But that in itself made me stream what it is. That's what we're going to be streaming now. That's what we've been streaming for the last half hour. And this is gonna keep on going, guys. If binary black holes can merge, then I'm gonna be merging astronomy with gaming on Twitch. I don't even care. I've sent some emails couple of hours ago. This is the direction the Spear Shaker wants to go towards. If nothing else, at least once a week, do something totally and entirely dedicated, without a fear with the whole Tetris bullshit. There's going to be none of that. If we're doing something that Twitch is like not enthusiastic about, fuck it. I'll end up doing it somewhere else then if I have to. This is the direction the Spear Shaker universe is going to take. Gaming and space, the universe, all the cosmos, those two things, they can work together. And I'm gonna those are my two passions. I'm very passionate about them. I'm gonna try and make it work. Let's see what happens.
Force pulling you.
For sure, Chris. For sure, Chris.
Is the shape of the universe being curved in such a way that you're falling towards whatever's at the bottom of that curved hole.
Yeah, Bob.
So if you're a science fiction geek, right, you've probably heard the term gravitational well. And that comes from Einstein's description of gravity, that gravity is this shape of space and time together. That when things have a lot of gravitational strength to them, they create a deep gravitational hole, a well. And so you feel the force of gravity when you are falling down the well. So gravitational waves are a part of that story. Gravitational waves are the idea that that shape of space-time can move from one place in the universe to another.
Gravitational waves were predicted by Einstein just a year after he developed his amazing, counterintuitive, unexpected, innovative
Asperger. I have one upstairs.
Even when he made that prediction, he actually wrote himself, yes, these waves must be produced, but there's no way we'll ever detect them.
It's a gigantic L shape. And that L shape is 4 kilometers from the corner building where it is, out to one end is 4 kilometers, and from this corner out to the other end is 4 kilometers. And we are constantly trying to measure the distance from that corner out to the ends of both of those arms. And the way we do that is we shine lasers back and forth, up and down the L. And we time how long does it take the laser to go one way and come back, and we compare it how long it takes the laser to go the other way and come back. And if we shine the laser out and they get back at the same time, we know the arms are exactly the same length. But if a gravitational wave comes by, it stretches one of the arms. It makes it longer. And so the laser that went down one of the arms takes a little bit longer to get back.
That is incredible. This is just incredible. This is just incredible.
Inherently an interdisciplinary collaboration. The center I direct here at Northwestern especially focuses on how astrophysics interacts with other disciplines. The same is true for our LIGO group here at Northwestern. So I work on astrophysics and data analysis. My colleague Shane works on astrophysics and data analysis across the gravitational wave spectrum. And another colleague of ours, who is not an astrophysicist, but is a physicist working in electrical engineering at Northwestern, is focusing on the laser physics aspects of this enterprise.
This is just absolutely mind-boggling, ladies and gentlemen. We're witnessing history. This is just
my Northwestern office going through my mail, but I always keep an eye on email, and I was receiving a few emails that with little tidbits saying there's something weird in the data. Has anybody seen this? Has anybody looked at that? I've ended my day, went back home, picked up my 3-year-old daughter first, went back home. I was ready to start preparing dinner and setting up the table when I get a text message. And I'm thinking, oh, it must be the weird emails. Oh my goodness. And then I drop everything, family and everything. Later at night,
she dropped the little 3-year-old. You heard her say it here. She dropped the family. Poor little girl. But, you know, science first, I guess. Not safety, science. Science first and then safety.
I have to tell Shane, who's my collaborator at Northwestern. So I emailed him late at night. It was almost midnight. I know Shane would be up because he's always up. And I said, Shane, have you seen these emails? And then I start forwarding emails to him and realizing, oh wow, there is a binary black hole gravitational wave signal in our LIGO data.
Fuck my life. That is a binary merging black hole in our, that is just.
I find myself wanting to pinch me and say, is this really happening?
And now we're going to do all those things that only we've kind of imagined we could do, or that we want to do.
Incredible stuff, people.
And that's
just
really
crazy.
What this is all about now, is that finally this thing we've been waiting around for 100 years
to
figure out if we can do, we know we can do. And so now it's all science all the time from here on out.
Soon they'll be putting LIGO equipment in your iPhone 7S. And you'll be I don't know, ordering coffee from freaking some franchise, and you'll be like, oh, look, let me tweet my friends real fast because I just detected some gravitational waves because of some cataclysmic event back 1.45 billion years ago. My phone can pick that shit up. But now, right now, we're super excited about this. This is absolutely incredible stuff. Absolutely incredible stuff, guys. Again, they've been, you know, for a couple of months now. They've truly been seen. These two, right, that we've just been watching. They've sat down now and said, you know what? Before we go crazy, let's make sure our equipment isn't fucked. Let's make sure the laser isn't screwed. Let's make sure the mirrors aren't foobarred. Let's repeat. Let's look at this again. And for months and months and months, they're like, well, we've been looking for this, but it can't be. Like, even Einstein said, we'll never find it. But, like, it's, I guess with science, a lot of it is, if you remove enough questions, you're left with one certainty that this has to be gravitational waves that we're detecting. Absolutely mind-boggling, guys. Crazy ass stuff. We're all going to benefit from this. Not necessarily, me personally in my lifetime, but for sure my kids. For guys, the technology we're just going to spring out after this kind of event, it's just mind-boggling, guys. Crazy stuff. They'll be pudding on my iPhones. I hope so. Pudding, you say? Yes, exactly. I agree. Have you read about the possible anti-gravity effects of superconductor sphere? I have not. Not yet. Not that I realize. I have not. This sounds good. I like this word, indie. Always remind that's Indiana Jones, right? Indie's Indiana Jones. That's what they used to call him. Beautiful website, space.com. Copernicus, Galilei. Galileo, right there.
Gravitational waves have never been detected. We're literally creating a new branch of astrophysics right now.
Fuck yeah.
Gravitational waves are the sounds of the universe. Up until now, we've been deaf to what's happening in the universe, and we're about to turn on our ears.
These guys should be, man. Freemasons, most of them, obviously. Bellatrix, Orion, Betelgeuse. Betelgeuse or Beetlejuice. I'm so super excited, guys. You wouldn't even believe. Guys, this is like for real. I really mean this. This is the first step. The first step. Motherfuckers gotta be Freemasons. Not necessarily, but the big ones were, for sure. Look at Isaac Newton, man. But that doesn't mean that they're bad people, right? I'm not saying, I'm just pointing out things that oftentimes get left out for purpose reason. But this, guys, this is, I really mean this. This is just such magnificent times we're going through. It's so exciting to be part. I'm really happy to be a part of witnessing this. This is gonna change everything. So beautiful. That's a nice little video.
Looking up at the sky with telescopes, we didn't stop doing it. We're never going to stop listening for gravitational waves.
That's just incredible. Absolutely incredible stuff we're going through right now. What's this we're watching now? Turtle in the woods, welcome. Welcome, welcome. Very loud here. Because guys, like at the same time, what they're just joining so much information. The fact that they're celebrating, or we are all celebrating, the fact that we can actually tell that not only do black holes exist, not only do they run around in binary systems, but they can also end up merging, and that, you know, these footprints of such merger actually happen, and we can now hear them, and we knew they were out there to be heard. We just weren't kind of tuned properly. It's just incredible stuff. It's so much fun. The event horizon, people. You're just at a standstill. Nothing changes. This is a fantastic movie. Fuck, this is a nice movie. What about the sound here? Let's look at that again. I didn't realize we had time here on our side. Check this out. This is all in under 1 second. It's a beautiful movie. This is all in under a second, people. Absolutely incredible. Riddick, welcome. Yes, Riddick. I had it yesterday as well. Didn't just grow overnight, I promise you. Look at this. Boom, 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 boom. Saka! A thunderclap in the fabric of time. Beautiful stuff. It's a fungal infection. SXS, simulating extreme space-time. Guys, I'm telling you this right now, man. Sooner or later, if I've interviewed game devs, sooner or later I'm going to be asking these people questions, man. I'm going to make sure they believe nothing. No, wait a minute, that would make no sense. That is just absolutely incredible stuff here, guys, that we're witnessing here. Let's just get out of here. Historic first, what's this all about? Lots of videos. We saw these two dudes speak, right?
It's a catastrophic event we just observed.
How about we go crazy ass stuff. Guys, we're going to be doing a lot of really fun stuff with regards to astronomy on this channel, guys. We really are. We're going to do this, I don't know, maybe on a weekly basis. We'll see. We shall soon see. With this completely new way of examining astrophysical objects and phenomena, gravitational waves will truly open a new window on the universe, providing astronomers and other scientists. This is the beautiful part. They already know. This is for everyone. This is for us. This isn't just for the astronomers. This is for dentists. In a decade's time, we're going to be reaping so much stuff. Oh, beautiful stuff. Gravitational waves were first predicted by Albert Einstein in his famous 1916 paper on general relativity. He knew. No, not. It's not like he knew. He came to the understanding that they had to exist. For him to be right, these things have to take place. It only makes sense. Crazy ass stuff. Spotting these space-time ripples is a serious challenge. As gravitational wave passes through Earth, it squishes space in one direction and stretches it in another direction, which is why they have that L shape. Crazy ass stuff. We'll be dropping black holes on cavities. No, but I'll tell you nice. Like if we could create like a mini black hole, and I could just throw it inside the root canal and then pull out the black hole again. The black hole would kind of just suck up everything inside the root canal, and I'd have my job done. I just have to pack it again. Just hermetically seal it. It's good stuff, people. Absolutely good stuff. If a gravitational wave passes by, it will compress one arm of the detector and stretch the other. Crazy ass stuff. With a cube and a marble? Let's have a look at this video. Paul McNamara.
So here I have my representation of the universe. So for everyday life, our universe is flat. We drive along the cars, we walk along the street, we have a flat universe. But then Einstein came along and he said, well, that's not quite true. The universe itself is actually like a fabric, and everything which is in the universe creates that fabric to change its shape. And I have here, this is a dummy of a Lisa Pathfinder.
Yes, Steve, well said.
46 millimeters on the side. It's made of tungsten, not gold platinum, but it weighs about 2 kilograms. So if I use this to represent my black hole...
Fuck, that thing weighs 2 kilos? Holy shit!
That space changes, space warps around the black hole. Now I now have my marble, this is my little planet, or my other black hole, and I let it go round. You start to see that it orbits, and it orbits quite slowly, then it gets faster and faster and faster. And just before it gets to the bottom, if we do it again, if we look at the black hole, you see the black hole starts to oscillate. And it's this oscillation which then creates the ripples in space which are coming out through the universe, and these are the gravitational waves. And these are the things we're trying to measure with the future gravitational wave detectors, of which LISA Pathfinder is the first step.
Nice stuff, man. Nice stuff. That little piece of tungsten, man. Density on that metal, quite incredible. Look how small that shit was. 2 kilos in that hand. What's 2 kilos? Like 5 pounds? 4.5 pounds for you guys? Sinkala, welcome. Yeah, chairs from the future. Did you see the invisible humans seated though, Sneebro? Or did you not? You guys all saw the chairs, but who saw the invisible people actually seated in the chairs? None of you guys did, because you're not paying attention. LIGO is operated by scientists at the California, so that's Caltech, right? And MIT. 1,000 members. Man, 1,001 now. I'm going to be one of them, homeboy. 83 institutions make that 84. Spear Shaker Institution for Higher Conscious Development in Humans is also associated to this. So we're very LIGO friendly, guys. Very, very. He obviously works out. Yeah. He grabbed those 5 pounds, those 4.5 pounds like they were nothing. So yeah, guys, we've been, I guess, for the very first time, kind of, well, we haven't actually, this is not the first time we've run into, like, a space episode, I guess. But here's something that I want to show you guys, okay? There's this website here called Slew. I only found out about this today, okay? So Slew is a community, basically, where the interesting for me would be, so they have live shows. Okay, let's look at this live show. So this is actually not live. Well, they're broadcasting live, but this is
University.
Shut up. This is sorry, Will, didn't mean to cut you off like that. Very rude of me, but do be quiet, please. So this is obviously all recorded from last year. But the interesting thing for me is that SLU members, and SLU members have to pay, I think it's $5 a month. You can join for free and get the first month for free, but then it's $5 a month. Now, SLU members get to fuck around with live telescope feeds. That would be very interesting for myself. Okay, for me to kind of hop on some kind of observatory. Partner observators. It'd be very nice to actually hook up with like I said, with would be awesome here. Would be for us to actually take use of or take advantage of somebody else's telescope and just ride with them. I think that would be an awesome thing. Don't forget about Dead Space. Spear, you've played that on stream? Yeah, I have played that. I have Dead Space 2 to play on stream as well. But we don't have to keep it. We're gonna stay away from gaming as long as we're doing this. As long as I'm doing this, there's nothing gaming related here at all. Twitch plays Explore the Universe. Yeah, I'm sure there are many games. I mean, we can go into. I can start playing Kerbal Space Program if I really want to. Actually, I've been meaning to do just that. But I just wanted to let you guys know that there is a lot of stuff going on right now, and like I said, astronomy is definitely something that I want to get into again. Dare I say the word again? Even I've never really gotten into it in the first place. Not like properly. Because these are all the events that are happening right here, guys. Next Friday, we're gonna see. We can jump into this thing next Friday. If I become a member to these guys, and we can just chill and check out some stuff, and just look at the stars, man. Look at some planets. Look at some deep space objects. I would love that. Mindscape, welcome. Kerbal Space Program is awesome. It's hard. It is hard. I've managed, but I managed to by myself orbit and get into geo orbit, I should say, and work with apogees and perigees. By the way, the moon is in absolute perigee. Has been since yesterday. So we're now losing the moon. The moon is the closest that it gets to us as of 2 days ago. So now she's leaving us a little bit. I guess she's heading towards perigee, apogee, I should say. So she was in perigee. But this is definitely something, guys, that I'm going to be doing here for sure. I think this is something that would be very, very cool here. Let's look at this. Like I said, these shows, man. I would love to Jupiter in opposition in March. Like, there's always something going on here. Actually, I've already emailed these guys and said, you know what? Like, can I rebroadcast live some of your shit? Is that okay? I did that just before I started the stream, actually. Like I said, I do want to do this. I want to merge. I want to marry these two passions that I have. Need to head out, but cool to see you doing something different, Spear. Thank you so much, Snebro. Much love to you, Snebro. You do your thing, homie. Guys, Snebro is a good friend. He's also a streamer. He also plays the Mean Greens. He also plays a whole bunch of video games. That's the only thing I'm going to say about video games, actually. Please go check out Snebro. He's worth checking out. He's a very cool guy, very chill, very easy peasy. A passion polygamist. Well, I've never hidden this. I really like that. It's like a passion in the making. It's really weird for me to even describe. I've always been like enthusiastic about it, but never truly passionate about it. And it's kind of in the making. I really want to head in this direction. I've mentioned this late last year. and this kind of stuff. Again, other things that I'm kind of looking towards doing is always checking out the night sky. So something that would be interesting for us would be, I don't know, during the course of the strum, just to find like, 2 minutes, 5 minutes, maybe at the very beginning of the stream, maybe at the very end of the stream, just to kind of recap what's out there tonight. Here we have the constellation of Aries with the brightest star Hamal, and obviously the moon is going to be extremely close to that. So if you do happen to have clear skies tonight, which I don't, because I actually have a really bad weather forecast, with a lot of issues actually. Hope this weekend goes well. Again, here we see tonight, February the 13th, so this is always up to date. You might not see the rather fake constellation Aries and its brightest star Hamal to the north of the wide waxing crescent moon. Waxing means it's filling up, right? Moon waxes and wanes. And it's not gibbous either, so it's just a normal waxing crescent moon. When you see tonight's moon, you might also enjoy knowing it is in part of its orbit that's carrying it away from Earth. Okay. What's more, over the long course of time, the moon's mean distance from Earth is increasing as well. So what we have here is, actually what I was mentioning, the whole apogee and perigee. Here's where the moon is the closest to us, and here's where the moon is the furthest from us. It ranges from 360,000 kilometers to 400,000 kilometers, I do believe. Right there are the numbers. So right now, the moon 2 days ago was at 360,000 kilometers away from us. And of course, when it's in a fortnight's time, obviously, or should I say in half a lunar cycle, it's going to be obviously at the apogee, meaning it's going to be at its furthest distance from us at 405,000 kilometers an hour, an hour kilometers. Here are the retroreflectors that some of you guys mention so often. Not reflectors, but these are retroreflectors. Very, very actually interesting concept with regards to the way the prisms work on these things. Yes, of course, Mindscape, absolutely. The moon has mass. The moon has enough mass to create the tidal effects. We all know this, that the moon is directly responsible for a lot of meteorological phenomena, including this very calculated tidal effect on the planet. And if the moon is closer to us, that pull will be for sure stronger. Absolutely. Almost feel like a scientist answering questions here. That's not what I'm about. But I'm just here to share. I know nothing, guys. I'm just here to share passion. That's all it is. And if nothing else, I would love to have even one person become even remotely interested in what's above. That in itself, for me, that would be 10 times more important than being partnered. Faux show. So check this out. The bottom line here, the bottom line, which of course isn't like the lowest line. It is the bottom. The bottom line theoretically is actually this one. Okay, but the bottom line here is we have a receding moon on the night of February the 13th. That's tonight. In two ways. This is the interesting part of it. The moon has passed its monthly perigee, or its closest point, and is now moving away from the Earth again, further away. Over the long course of time, the moon's mean distance from the Earth is also increasing. So this is constantly happening. Every 2 weeks, the moon is going to be going further from us than it has been before. Okay? So it's always interesting to see our brother. I was reading some things about the moon, actually, here we go. About the simulations here. Mindscape says, when the moon is, Sakura says, Spear Shaker, you should really read up on the EM drive. I have no idea what that is. Electromolecular drive. Simulations suggest that at one time, at the time of the moon's formation, so at the very beginning, some 4.5 billion years ago, so this was actually a lot older than this dual binary merging black hole system collision, okay? That the moon was only 20 to 30,000 kilometers away. Can you guys believe that? The moon, like you could almost touch it. That's why rats believe the moon looks like cheese, I guess. That is just absolutely mind-boggling. 20 to 30. It's like 10 times. It's actually more than 10 times that now. It's actually more like 20 times if you think about it. Way back then, the Earth's day might have only been 4 to 5 hours long. Think about that. It almost feels like the whole planet felt like Finland. Complete darkness all the time. Just a little bit of daytime for you to, get a little bit warmer. So you'd have 1,400 days in a year, people. Isn't that sick? How much gravity effects would that have, and what would that do? That would be sick, right? You'd have the biggest freaking tidal phenomenon ever. A 24-hour stream would be 6 days. Well, no, a 24-hour stream back then, a 24-hour stream would be like a couple of minutes. I would totally sign up for that. I'll do 24-hour stream the moment the moon is back to where it was, like 30,000 kilometers away, just whizzing around us. Crazy ass stuff. Really super excited about this. So your workday would be short. What about our sex lives, man? They would be like all night long in 2 seconds. All night long in 2 seconds. That'd be just out of this world. So again, guys, this is what the moon is doing right now. So we know, this is what the moon would look like to now. This waxing crescent moon. We also understand how Aries works. Okay, the most prominent of constellation. Well, it's not the most prominent constellation, but it's definitely the most important constellation as far as the zodiac is concerned, because that's when they start their counting. I used to know why. I can't remember why Aries is so important. Why they start always with Aries. I guess it's because Aries is in the ecliptic, in the vernal equinox. Is that what it is? That could be it. I can't remember. Funky Monkey. Hey, up, how goes? Okay, I love you, Funky. Does that mean our days are getting longer over time? Because it feels that way. Well, they were saying, let me see here, that the day will become obviously longer and longer because the moon is actually moving further and further, dragging so here's the moon's distance is increasing by almost 1.5 inches per year. That's quite incredible, right? If we think about accuracy, right? We think about accuracy. It's 400,000 kilometers away, but next year it'll be 400,000 kilometers and 1.5 inches further away from us, no matter what. So here we have some answers for Mindscape, actually. Tidal friction with the Earth's oceans is responsible for this long-term increase of the moon's distance. So it's causing the moon to spiral into a more distant orbit. Tidal friction also slows down the Earth's rotation. Okay, lengthening the day by about 1 second every 40,000 years. So, yeah, time almost feels like it's slowing down, although it isn't. It's just the days are becoming longer. Tidal friction. I have yet to understand how that works. Tidal friction. How does that even work? Let's learn about tidal friction. Tidal friction. I guess we can look at it this way. Let's see what happens here.
All that water, vast oceans of water sloshing back and forth, pouring out of the moon, water
Ah.
banging into itself. And more
Mm.
important, if you go down to the bottom of the oceans, all that water dragging and banging against the seafloor
Mm.
literally slows down the spin of the Earth.
That makes
It's as though
sense.
the moon is putting its finger on a spinning top so that very slowly days on Earth get longer, about 2 seconds longer every 100,000 years.
Ah,
So
it's
over
confirmed. That's confirmed. We heard 1 second every 40,000 years. This dude says 2 seconds every 100,000 years. So I'm getting dressed for work. I will be back on at work. GG, brother. I hope you stay dressed once you get at work. Like, make sure you dress not only appropriately, but in a fashion that you will allow you to remain dressed throughout your, time at work. Last thing you would want to happen is thinking you're dressed, leaving for work, and then show up at work, be like, oh, fuck, somehow I got undressed on my way here. Very bad. Pay attention to detail.
time, that adds up. 400 million years ago, a day on Earth was only 22 hours long. 200 million years ago, it was 23 hours long. Today, 24 hours long. And 400 million years from now, each day will be 26 hours.
That longer days means faster years, yes? No, shorter days meant faster years, correct? Will that explain why the old patriarchs all were very old men? That's some lag, right? Now I'm thinking about like the on a biblical term now. Would that explain? I mean, obviously, we're talking about millions of years ago now, in comparison to the so-called Bible story. Because that's always been something that's always intrigued me. How those old dudes, Adam and Seth and his offspring, and all those dudes, right up to Noah inclusive, how they all ended up nearly reaching 1,000 years of age. 1,000, if a day is 22 hours, the whole year thing. That's interesting. I'll have to look into that actually. That is quite interesting. So okay, this is tidal friction. Days don't affect years at all. This is true because of course it's our orbit around the sun, but it's still going to be allowing things to be perceived as being faster, right? In that sense. Yes, of course, Bob. I don't forget these fundamentals, but it might be all a question of perception. 8% older. Welcome, Irish, by the way. Less or more actual time is happening. Well, I wonder though. How long was a year 10 million years ago? Let's look at this. A year, of course, is all about the sun and things, right? We don't want to get all fiscal year. Let's stay away from that bullshit, right? Variation in the length of the year and the day. Let's look at this. The exact length of an astronomical year changes over time. The positions of the equinox and the solstice with respect to the points, with respect to the apsides of the Earth's orbit changes. Exactly. So, Difference from 2000, positive Italian free are greater than the length in 2000. The years were long. They were faster there, Bob. This is what I'm telling you, brother. This is very important for us, guys. This is what Plato called the perfect year. This 26,000 year cycle. I mentioned this all, and then we have the galactic year, right? This is the Yuga cycles. In India they call it the Yuga cycle. But am I getting this correctly here, Bob? Like the years have become longer now. Is this correct? Yeah, of course he's right about the sun rotation. The length of the day has zero impact on the length of the year, just like Frag Bob says. Wait a minute. Wait a minute. You're misunderstanding something though. If the orbits are changing from the moon with the sun from the moon with Earth, then are we also losing distance over the sun? Because this is what it looks like here. Look at this, guys. This is the year length distance from 2000. Each planet's movement is perturbed by the gravity of every other planet. This leads to short-term fluctuations in its speeds and therefore its period from year to year. Moreover, it causes long-term changes in its orbits and therefore also long-term changes on these periods. So here we have the tidal drag, which what they were calling tidal friction, right? Tidal drag, I guess, the same. Between the Earth and the Moon and the Sun. Hang on. Tidal drag between the Earth and the Moon and Sun increases the length of the day and the month by transferring angular momentum from the rotation of the Earth to the revolution of the Moon. Since the apparent mean solar day is the unit with which we measure the length of the year in civil life, the length of the year appears to decrease. The rotation rate of the Earth is okay. So that is actually static. Is that what they're saying then? The planets all revolve around me. Yeah, that's I'm sure what you would love to have. The length of the year is measured by the time it takes Earth to go around the Sun once. It has nothing to do with the speed Earth revolves around its own axis, which is a day. Absolutely sacred. But my question here is, if we have my issue here is if clearly we have the moon rotating or orbiting our planet and it's clearly losing its grip on the planet, is the sun not losing its grip over us as well? I'm not saying anything, I'm asking questions. Don't tell me shit that we all know and understand, like what makes a year a year. To rotate around the sun. Okay. Like, that would make perfect sense. I'm just wondering. I ain't saying shit. I'm asking questions, guys. That's all I'm doing. Asking questions. Don't treat me like an idiot, though. Let me look into this, though. So, distance. I can't even spell. Distance from Earth to Sun. Let's look at this here. How far is the Earth from the Sun? The Sun is the heart of our solar system, not of the solar, of our solar system. Arrogant fuckers. All of the bodies in the solar system, planets, asteroids, comets, revolve around it. This is true. The distance from the Earth to the Sun is called an astronomical unit. This is also true. Which is used to measure things. This is also true. So we have, the AU is not allowed to change then, right? That's kind of why we use it in the first place. If that changes, then of course our year would change. Astronomers use the AU for measuring distances throughout the solar system. The Oort cloud, right? The distance to the nearest Proxima Centauri. I thought it was Alpha Centauri, our closest sun. Light years. Okay. Light years. So the AU is the average distance from, yes, of course. We also have perigees and apogees. Solar, of course. Earth makes a complete revolution every 365. We know this for a fact. However, Earth's orbit is not a perfect circle. It's shaped more like an oval or an ellipse. This is also correct. Over the course of the year, Earth moves sometimes closer and sometimes further. In January, right? Which is always weird for me. Like, when we're closest to the sun, it's when we in the northern hemisphere actually are feeling the least effects from offset sun, but that is actually the way it is. The furthest from the aphelion, so we don't call it the apogee or perigee. It's the aphelion and the perihelion. Where does it say perihelion here? Helion as in sun from Greek. Finding the distance. Historically, the first person to measure the distance was Aristarchus. Oh, he's an intelligent guy, man. In more recent times, Huygens calculated the distance from the Earth to the Sun in 1653. He used the phase of Venus. Okay. Smart dude. Cassini used a method involving parallax. I used the parallax shift to take X-rays, by the way. So, with the advent of spacecraft and radar, there are now methods for making direct measurements between this and that. So, if an observer on Jupiter used the old definition, roger that. So I guess that's it. I guess that's actually it. Yeah, we're pretty fixed then. I mean, if we're going to be using the AU, then that should be a very fixed value, right? That should not actually change that much. That's interesting. Good stuff. We've learned about tidal friction today. That's fantastic. And gravitational waves, man. That's even more out of this world. So we agree. We're just saying shit differently. Of course, we're always in agreement here. I'm just asking questions. I'm just wondering about stuff, right? Think of it like the conversion formula changing. Instead of 16 ounces in a pound, there's 6 the ounce doesn't change of what it makes a pound. Yes. I like toast. Think I do too, Grog. There's no actual change. It's just a perceptual shift because we're retarded and make up strange distinctions based off shit that is somewhat variable instead of a fixed unit. Absolutely. We just like to be special, I guess. Really happy about this, guys. Really, really, really super happy about this. Yeah, so we're pretty much done here with regards to, celebrating, or at least I'm definitely celebrating this amazing feature that mankind, I guess modern man, has been able to do here. Really, really happy about this. We're gonna go for a 2-minute break. We're gonna leave the gaming talk show. I had a lot of fun. I hope you guys had a lot of fun. If nothing else, this is just the tip of the iceberg, guys. I will definitely make this happen. My instinct says use words like regularly. I want to regularly have something to do with what's up above us. I we must never forget, as above, so below. As above, so below. And I really want to, take advantage of this wild, wild west crazy times that Twitch TV is still allowing. And yeah, I'd really like to incorporate something systematic as far as space goes into the strum. We need to check the email. Roger that. Very interesting subject matter, for sure. Everything that's above that. I mean, it can't be all about freaking Super Bowl, man, right? There's more shit. There's more shit than going on in the Super Bowl. Well, to be fair, the day is somewhat useful measurement of time for us on Earth. It's a pretty shit measurement of time when you're trying to describe very specific things like orbit around the sun. Absolutely. It's why you end up with crap like leap years. Yeah, absolutely. Absolutely. We're always having to correct shit. We're always having to correct shit on a very small scale because things are just out of control. But yeah, guys, like I said, I've had a lot of fun. We've been doing this now for pretty much an hour and a half now, which for me, of course, is absolutely outstanding, guys. Never this time last year did I expect for us to do anything like this. I'm really excited, like I say, about especially this website here that I showed you guys earlier, this slew thing. If they give me, like, if they say, yeah, you know what, Spear, it's absolute. I think it's great for you to, stream our shit on Twitch and get your community involved. I'm totally fine to subbing to these guys and paying them $5 a month, just so that I can actually tune into these guys' telescopes. And like I said, these guys they've constantly got stuff going on here.
At that time and looked out the window, and there it was. Imagine that, 50 meteors per second exploding, radiating across the sky. She was convinced it was the end of the world. What else could it be? And
we're listening to someone here speak about something. They've got their YouTube. These guys are streaming live into YouTube. Chocapi, como é que é? Welcome. Yeah, so these guys have, started to stream live very recently now. It's a 24-hour strum. And what the fuck? Space junk crashes into Earth's atmosphere. Say what? Oh, that looks awesome. Look at that. Look at that, guys. Isn't that beautiful? Isn't that freaking beautiful? It's good stuff, man. Good stuff. So like I said, guys, we're going to take a 2-minute break. Let's find some music here for you guys. Let's kill the monitor capture. Boom, just like that. Let's press this as well. And yeah, guys, like I said, I've had an amazing amount of fun. I am so stoked about learning things. Not in a million years did I realize that, like I said, a lot of us know that the moon is kind of departing from the Earth. Little did I realize it was due to tidal friction. Little did I realize yesterday when Bob sends me his link that that would kind of really drive me to want to go astronomical in the Spear Shaker universe. I actually really thank you for that, Bob. I genuinely mean this. Yeah, let's find some music here. Oh, this sounds like a nice song. It's called DMT. Never go wrong with a song called DMT. Tenho micro fudido.